Bienvenidos, Ushamdi, and welcome Anne Arundel Community College learners from the Spring 2023 semester taking the CTS-233 Section 400 Network Programmability course. This is the Cisco Networking Academy's DEVASC 200-901 Certification Exam Preparation course, and in this lab, 8.3.7, we're going to be diving into RESTCONF. And now that we've taken a look at NetConf and we have an understanding of how that works using SSH and XML, we're now going to turn our focus to RESTCONF, where we're now looking at using HTTPS, and we could use XML or JSON, but our focus in this lab is going to be on JSON. So here's what you're going to learn. You're going to learn how to configure Postman to send GET and PUT requests, and we're going to be doing that to our CSR 1KV, and we're going to see how RESTCONF is a much simpler way, at least from my perspective, as to how to dive into that model-driven programmability as opposed to using NetConf and having to deal with all of that XML. But again, that is what RESTCONF and NetConf are all about, model-driven programmability, and we're focused on those Yang data models. So how are we mapping between NetConf and RESTCONF? Well, this is actually what's happening. So remember, we had the edit config or the get config XML tags that we would work with. Well, with RESTCONF, it's just simply going to be to create a resource, it's a post. To get resources or retrieve data, it's a get. To replace a data source, it's a put. And to delete a data source, it's a delete. And so these are the mappings that we're going to see. But again, from Module 4, we are already familiar and we hit the ground running here with RESTCONF because we know the HTTP verbs, we know how RESTful APIs work, and we know how the REST structure is all defined. So let's go ahead and let's dive in here. We're going to jump over to our DevNet virtual machine. And again, they've got some basic things here. So let's just make sure that we can connect to, or I shouldn't say connect to, but we have reachability over to our DevASC virtual machine. And then they want us to SSH over there. We're going to do some configuration information. And so let's do a Control-C, say SSH Cisco at 192.168.1.129. And we're going to get logged in with Cisco 123 exclamation mark. And so here I am on, and let's actually fix that. So we'll get into global config here real quick and we'll sort the host name out and we'll go all lowercase, CSR1KV. All right, there we go. Okay, so we're on the device. Well, now we need to make sure that this IOXE device is ready to go. So if I was to say show platform software Yang management proc or process, it's going to show me what daemons are running here, what processes are running with respect to NetConf and RESTCONF. Remember, the NC client that we use in our Python script, well, NC SSHD, remember, NetConf leverages SSH. So here's the daemon indicating that that is running. You may see different results here, by the way, especially with the Nginx, right? So Nginx is just a lightweight web server, and we've got it right here, and it is already running because I've already run these commands to make sure that everything was going to function the way it was supposed to. And so let's go ahead and move on here. If let's say that the RESTCONF would be the remainder of these processes, so it would be not NC SSHD and not Nginx, but everything else is related in some form or fashion to RESTCONF. Now, the lab quickly points out that, hey, we really don't need to have an understanding of what confd does, but, so the confd is a management agent that works with programmable interfaces. NESD is the network element service daemon, and this is part of Cisco's network service orchestrator, this NESD right here. So when you hear Cisco NSO, network service orchestrator, that's what this NESD daemon is doing. It's providing an interface that's programmable for network devices using Yang models. And so NESD, super important, right? So it's good, know about a couple of these things and you can punch up the rest of them. But again, at the end of the day, that is the big one here for NetConf. That is for the web server. And then we could confidently say that everything else is kind of going to be related to our RESTCONF setup. So let's go ahead. If I didn't have the web server running, we would do something like this, and then I would say IP HTTP authentication is going to be local. Authentication is local. There we go. And again, local just meaning it's using the local AAA database. And what's the local AAA database? Well, it's just the username password stuff. I was going to say more. The username password stuff that you see configured here on the router. All right. So again, if I was to come back and say, let's get out of global config there. If I was going to come back and say show platform, we should see the same thing. And this is what you should be seeing after you run those two commands right there. Yang management proc. You should see that everything is running. All right, so now it's all about Postman, right? And we've already seen Postman. We used Postman way back in Module 4. Now, my recommendation again is to go ahead, sign up for the free Postman account, because then you're able to curate and organize via workspaces and collections all of your API work. And so for here, this is my workspace, right? You can see I've been messing around with different workspaces, but AACC, and that's this spring semester. And then what do we have in here? I had some GET requests that we did, some posts, some practice requests. Well, now we've got, maybe we want to organize things by Lab 837. And so before we do that, one of the things we want to do is we want to go to File and we want to go to Settings, because we're going to disable the SSL certificate verification, and it looks like it is already off. All right, so that was already off for us, so that's a win. So we'll go ahead and close that out there. And so now we're going to use Postman to send GET request. Well, how do I do that? Well, I just click on Add Request. So this is going to pop up. What's my new request name going to be? And I'm just going to say GET, and we'll say P4 for part 4, and what is that? Step 2. Step 2. And you could even put, the lab in there or whatever, but we've already got the lab name here, so we're good to go. Let's click on enter the URL. And so what is the URL here that we're going to put in? We're going to do HTTPS. Now, it's interesting. We turned off SSL verification, but we're using HTTPS. And that's because in RFC 8040, RESTCONF is no longer supporting, or should no longer be supporting, HTTP. Because again, there's no inherent security in HTTP. We need to be using HTTPS. And so that's why our RESTCONF GET request here is going to use HTTPS, but we've disabled that SSL verification. So we're going to put in the IP address 168.1.129, and then we're going to put in a / and RESTCONF. And so what are we doing here? Well, we want to access the RESTCONF service in order to see what we're going to get back. Now, let's go ahead and click Send. And here you go. We end up with an error. So we have to enter authentication credentials here because we get this access denied. So let's put in the authentication credentials. So under the authorization tab, you can see where it says inherit from. And this is where we're simply going to say basic auth, which is right there, which basic auth is just username and password. And you saw some of the different authentication methods that you can use. And so we've got Cisco, and we'll say Cisco 123 exclamation mark. Let's show that password to make sure that we're good to go there. Let's click on headers, and you can see we've got some hidden headers here. Now, these are the different headers that are going to get sent. So there's our basic authorization. We've got no caching, Postman token, right? So here you can see some of the hidden headers that are going to be sent. So let's rerun that, and now we get what we would have expected to have gotten on the first request. But again, we have to log into the Cisco router with the username and password in order to get this information. So what we can do is we can actually set JSON as a data type to send and receive information from the router. Because what is this? That's not JSON, is it? And you can see it says XML. If I click JSON, well, it's still XML, right? So by default, with Postman anyway, we were getting XML. So let's go to the header section, right? And that's why we wanted to pull that header section up. And down here at the very bottom, we've got an empty key. Whoops, sorry. We've got this empty key right here. So what are we going to put in here? Well, we can put in the content type. And you can see once we start typing, it's going to kind of help us out here with some prompts. So I can say, yeah, my content type And what do I want that content type to be? Well, if I say application, you can see we've got Atom, we've got ECMA script, and then we've got application JSON, but we're interested in, and it should be a little bit further down here, I would think, and I guess let me type the rest of it out here. Application, we want /, and did I misspell application? Application, and we want /yang-data plus JSON. Now that wasn't there, so let's go ahead and see if that takes it. And that should, I'm just making sure that we've got everything, and that is the content type. All right, so the content type key, we're going to add another key value pair. And so let's do this. They want us to do something else under content type here. They want us to type in, the key field is accept. And there we go. And we're going to, oops, sorry. So we want to accept. And what are we accepting here? Well, we're going to be accepting application /yang-data plus JSON. So these values weren't in there. And let's go ahead and see. And there's a quick note in here. It says you can change the application yang plus data or yang-data plus JSON to application /yang-data plus XML to send and receive XML, but we don't want to do that. So let's save the request here because we've typed in quite a few things. And now let's send the API request to the server. And, excuse me, take a look at that. So we get back JSON data now. So we're saying we want to send and receive JSON data. And there it is. All right. So again, this just shows us the Yang library version. Again, it's all about model-driven programmability with Yang, yet another next generation. And it's allowing us in sort of a pseudo-generic fashion here to model the things that we want to do and the operations that we want to execute. All right, so now we're going to set up another GET request. Now, this was part 4, step 2. I could come over here and, try to do new or something like that, but you can also just do a right click and do duplicate tab. So then you keep all of the data and information that you had in here so that you don't have to do it again. And what are we going to do? Well, now we're going to go to RESTCONF. We're going to go to data because we're going to dig down here and we're looking for IETF interfaces interface. Oops, sorry. Interfaces interfaces. And so I'm going to go ahead and you can see the names are the same here. So we're going to modify this. And this is actually step number 6 here. And so then we can save that. And then let's go ahead and click on send. And so it should get the interfaces for me, right? And again, we're trying to get that, extract the open model, right? We're not pulling any of the native model information here. And so what do we have? Well, your output is definitely going to differ from mine. I've got a ton of stuff going on here. We got loopback addresses galore. Now, take a look at all of this very rich JSON data, which you could then possibly save that response to a file. And what could you do then? Well, you could write a Python script that goes through and you could practice your for loops, listing out the name of every device or listing out the IP address of every device. So all kinds of different things that you could do. But this is how you would get the JSON data from the device. So now we're going to use another GET request because we want to get specific advice. In fact, we're going to get a specific interface, which is Gigabit Ethernet 1. And so let's go ahead. Let's right click here. Let's duplicate the tab. Let's save the tab with a different name because this is part 7 of the lab. So now it's saved. And what do we have to manipulate? Well, sorry about that. We've clicking around there. We've got to manipulate up here where it says :interfaces, right? And if that shows me all of the interfaces, how do I simply get the interface that I am interested in? So I could say, whoops, pull that back, Gigabit Ethernet 1. And so this will be for Gigabit Ethernet 1. So I'm going to save that. We're going to click send. And there it is. There's the information for Gigabit Ethernet 1 because that's all we wanted to get. So the previous request, which I actually think I may have overwritten there, the previous request, which should have been for 6. Let's make sure we didn't botch that. Oh, I see what it's doing. So it's changing the name for both. Okay, so we'll just leave it that way. So for Gigabit Ethernet 1, what if I wanted to get loopback 1? Well, I would just type in loopback 1. And so here's how we can leverage the REST architecture with RESTful requests using RESTCONF, which is just simply sort of mapping its get and its put and its delete and whatever the case may be to what those netconf instructions and commands would be. And so then we end up with interface Gigabit Ethernet 1. All right, so it wanted us to do a show run because now what we're going to do is we're going to actually configure the Gigabit Ethernet 1, and I'm curious now as to why. Oh, because I think it's supposed to show DHCP. So we'll pop over here to, we'll pop over here to the, let's get to the router. There we go. To the router, and you can see here that we had some work going on there. So if I say show IP interface brief, and it shows, yeah, okay, all right. So it shows that IP address is assigned via DHCP. And so here's what they want us to do. We're going to use the exact same IP address. We're going to go from privilege exec into global config, interface Gigabit Ethernet 1. And I'm actually, and before we do that, if I said do show run interface Gigabit Ethernet 1, you can see that it shows IP address DHCP, right? So what do we want to do? Well, we want to go ahead and say IP address 192.168.1.129, throw that subnet mask in of a /24, hit enter, and hopefully we do not blow this lab up here. And show IP interface brief should now show that the method is manual, right? And I can't highlight it, but when you look up there at Gigabit Ethernet 1, you can see that it goes to the interface name, the IP, okay, yes, and then manual, right? So instead of DHCP assigning the address, we're getting it manually. So let's go back to Postman, because this is what they want us to sort of compare and contrast. And you can see when we've got let's do the Gigabit Ethernet interface. Oh, you know what? Is the output? Okay, good. We have the output here. Thank goodness. Okay, so you can see that the IETF IP IPv4 address, it's just kind of blank here, right? It shows the open brace, close brace, and that's because the address was gathered up using DHCP or assigned using DHCP. And now when I rerun it, take a look at what we get for the IETF IP IPv4. We now see in JSON output the assigned IP address. So if there's no IP address there, that would indicate one possibility is DHCP. Now, if we see the information here, we know that the address was defined statically. And so it's that simple, right? It's just like the MapQuest work we did in Module 4, where we have to figure out where down that model-driven programmability Yang data model sits the information that we're looking for, and then we can gobble that information up. And then the nice thing is we've got the API calls, the GET request that we were using here. All right, and so now that we know how to do the GET requests, let's dive in and let's do some PUT requests. So what do we have to do that? Well, I can just simply duplicate the tab here, and we're going to flip that from a GET to a PUT, and the interface parameter, right? So let's change that loopback 1 address, right? And you can see here we've got the interface equal loopback 1, and do we have everything we need here? Interfaces, colon, yep. All right, so we have to configure the body of the request to specify the new loopback. And in order to do that, again, we're going to be sending JSON data. So if we go to the body of the GET request we did on Gigabit Ethernet 1, you can see here that we've got the IETF interfaces, and actually, let's do, that was Gigabit Ethernet 1, let's do loopback 1. And so I'll just update this here real quick. So we'll say loopback 1. We'll get that specific JSON output, and there it is. And you can see that it's just that right there. And so I'm going to grab that because that is what we are going to copy. and use in our put request. And again, the put request here is for, I think it's part 5, step something or other. So we'll just say P5, step 2, and we'll click on save. All right, we're getting these conflicts because we were duplicating the tabs, but we're just going to roll with it. So we'll come over here to the body, right? So in the body section, this is where we're going to indicate what it is we're sending, right? So I could say that I'm sending raw JSON data, and then I could paste in that JSON data like this. And let's give ourselves some more room with which to work here. We're going to want to change the description, right? So that was my first netconf loopback. So let me say, this is now my RESTCONF loopback address. All right, and they don't want us to change. And you can see, so software loopback, that's good, false. And it looks like, well, it looks like the only thing we're changing here is the description of loopback 1. And I don't know why we've got that in there. It looks like there were multiple loopback 1 addresses. And so we'll wipe that out there. Whoops, sorry. Put the comma right in there. There we go. All right. So that should be, and actually we don't need the comma. There's not another element there. So that should be all we need. Again, I'm just double checking here. And so let's fly with this put request and let's see what happens. We should see a 201. I'll click on save. We'll click send. All right, so we've got a 204. The server successfully processed the request but is not returning any content. So if it successfully processed the request, but we're not getting anything back here in our body, let's go take a look at the router and let's see if that actually did what it was supposed to do. Show IP interface brief, loopback 1. Okay, so that, so loopback 2 also has the same IP. So we ran into this issue in the netconf lab. Let me say a show run interface, loopback 1, and there it is. Now I'm curious, we only see that for the one loopback there. What about loopback 2? Show IP interface brief, and what about a show run int loopback 2? Should not say that. Yeah, okay. All right, so this is now my RESTCONF loopback address, and so that actually worked. All right, so that is actually going to do it for Lab 837, where we took a look at the first half of Lab 837, which was working with Postman and RESTCONF. And we saw that it's just like using our RESTful API calls for the MapQuest API. We're sending GETs. We could do puts, right? All kind of the same concept, and we're doing it all with JSON data. All right, as always, thank you so much for watching, and I hope to see you in the next video.